screen as well. So we are on chapter 12, Multitenancy, that's the chapter name. So while kind of going over this particular chapter, I realized that most of the topics what we have in this chapter, they already kind of partially covered in the previous chapters as well. Um, but anyway, we'll kind of go ahead and then look at some of the interesting points what are being mentioned here. Just to kind of quickly brief, how does this book club works is what we do is for every chapter we kind of pick up a chapter lead, and the chapter lead basically take the responsibility of going over the entire chapter and of course sharing the knowledge. That is how it has been going on so far. So of course, if anybody wants to kind of go for the next chapters, we'll be more than happy to support you. And then if any questions and so forth, we'll be kind of help you in finding those answers, and then you can lead the next chapters if you wish. Yeah. Okay. The main problem what we're trying to solve here is you have uh, within a given company, within a given org and so on, right? You would be having multiple teams, or think about, or other way to look at is you may have you may have built something and you have multiple customers, right? And of course, by sharing the resources, we save money and time. So, like the way if you have like the way if you know that all these websites where think about the WordPress, right? WordPress hosting, right? Now for the WordPress hosting, they may have, or the ISP may have only one server, and they would be having multiple sites hosted for multiple clients, and they would be all separated by some kind of wall, right? And that is what even here that we want to look at how we can have um, a cluster or multiple clusters, or think of general in general how we want to kind of have the Kubernetes cluster being used by multiple teams. Now, there are two ways of doing things. One is, of course, you basically create one cluster per team, kind of a thing, and then one team has the entire cluster access they can control. In a way that you are not sharing resources, you are kind of just setting up one cluster per team, and they're responsible for that. So, of course, once you have that kind of setup, no other team is going to kind of come and um, use your resources, right? So that is one way of doing it, or you can think of it. I'm going to have one large cluster, and then I'm going to have somehow partition the cluster for multiple teams, right? That is another way of doing the multi-tenancy in the environment, right? So I have my notes on my other device. I'm just going to refer that and talk about the respective things. So yeah. Yes, I think I talked about both the things, whatever mentioned in the first introduction part here. So here is the one picture which was mentioned earlier, right? That you have for one cluster per tenant, and then you're going to kind of then have that tenant just access to that given resources. Now, what are the challenges if you go in that particular way? So first of all is resource overhead. So in production, typically, if you know that we are going to set up three nodes only for the control plane, and then of course you're going to have the worker node pools. So now, if you are setting up n clusters, your control plane is n into 3. That is the overhead what you have. And of course, the worker pools, the number of nodes what you have. So think about on this particular tenant, if they don't have enough workload, the worker pool machines are kind of idle, right? They're not using resources there. While on the other machine, you may run out of resources there. So these kind of challenges you're going to face if you go with this kind of tenancy, multi-tenancy, where you have one cluster per user there, or per tenant there. Then of course you would be requiring a team to manage that, because it's not just that you are going to incur the cost, At the same time, the cost is going to be also for the management as well, right? Because if you have multiple clusters, you have to manage them, you have to upgrade them, or all these things need to happen. So these things are there. But now with the cluster API, so if you look at our previous chapters, I think chapter 1 or 2, where we discussed about this thing, where the cluster API can create clusters for you on the fly by the cluster API calls. But still, um, it's kind of um, um, additional resource, or kind of a say you will have to still take care of the other stuff. Like with cluster API, what I can do is I can automate, right? I can automate the cluster creation, I can automate the upgrade and so on. But still, you're going to have multiple resources getting wasted there. But of course, it's a very easy to start with, because you can easily say, okay, one team, one cluster, one team, one cluster. So this is an easy to kind of get started there. Then the second way is you have the multi-tenant clusters. We have multiple tenants. Now this can be different teams also, not just a single person. So you can think about a tenant one has 5 team members, and they can connect to the cluster, right? So here we have one single cluster there, and here we are going to have only 3 control plane nodes and the worker nodes there, right? So when they kind of access, so they are trying to access their own piece of from the cluster, right? Now, of course, as a as a administrator of the cluster, you take care what kind of multi-tenancy you want to give. One way of doing it, you can refer as a soft multi-tenancy. So if you look at here, yeah, it is saying that you can have a soft multi-tenancy, and then you can have hard multi-tenancy, depending on how do you want to choose there, right? So in the case of soft multi-tenancy, it's kind of assume that, okay, you are the same kind of company, you are still kind of okay to kind of look at the resources and share resources and so on. But it can become challenging. So for example, let's say if one of the application on one tenant start consuming resources, right? And it can kind of eat all the resources in your cluster. So that's where it's going to fail. But if you go with the hard multi-tenancy model, where what we'll be doing is we'll kind of putting some resource constraint. So for example, we can say that, okay, this particular tenant cannot consume more than 10 GB of my entire cluster available memory, right? So once we establish that, then in that case, it would kind of, or Kubernetes cluster would enforce that. So in that case, your tenant would be able to use the resources only what has been given. So you can choose how do you want to kind of give the access, right? Yeah. Now, how do you kind of decide the isolation requirement, right? So of course, um, it depends all that, right? Like how is your team consist of, right? Do you trust each other? Or for example, if you deploy for two different customer itself, right? So there you require complete separation. So based on certain decisions like this, we can take a call, right? So for example, workload plane. So in that case, what we can do is we can have either a shared node, like node shared by multiple tenants, or we can dedicate it, say, okay, few nodes are being given to one tenant. So all of these things can be considered here. A control plane encompasses all the components like API server, controller, scheduler, and so on. Now, there are ways by which we can basically separate them out at a tenant level. So for example, I can say this particular given tenant have or has only access to a part of the cluster. So I assume that you know about the concept of namespace in Kubernetes terms. So the namespace, what we do is we kind of create multiple virtual cluster if you look at in an easier way. Now, once we have that partition, right, then what we can do is we can configure some of these RBAC rules and so on, and say um, this particular set of users can only access that particular namespace only. And for that purpose, we can take help of RBAC and other things what Kubernetes provides us. Then the next part is platform services. Now, for example, is it okay for you to kind of share the logging between the multiple teams? So, for example, if you have a team which is handling the logistics service, another team is handling the payment service. Now, all of their logs are going into the same log backend. So, for example, Elasticsearch, or whatever you may have behind the scene, right? And now, is it okay for them to share the same, or basically one team can look at the logs of other teams, or you want either separation in that in there as well, right? So those things also need to be considered. How you would basically set up the tenancy in your environment. Any questions so far? Okay,
If I could,
please go ahead.
the question that I have is there a consensus on what the best practice is? Because all these different possibilities
Uh-huh.
are indeed multiplying.
Yes.
And everywhere I go, I got a customer who's slicing and dicing it a different way. Is there a best practice? Is there a consensus?
There's
Um,
no consensus per se because see that is one of the choice what Kubernetes gives you in a way that you can decide how you want to have it. So that is how is there. So of course you have some of the best part of what is the book has been telling us about, right? For example, putting a namespace boundary, correct? It's giving you different options there. So, but of course, what I have seen there is you typically go with the namespace boundary and per application level, which I will talk about there. So,
sure.
but in general, as an open source, as a Kubernetes, the whole idea is that you have different options available to you, and then you can choose which one works best for you. But of course, I understand from your point of view that it's a bit challenging to kind of decide or
Oh yeah.
um,
Whatever my customer says is right, and if they each say something different, it's a challenge.
yeah. So
Yeah.
as a part of consulting, right, what as a approach we will take is we should tell them pros and cons of both those things, and then they should kind of take a call depending on that. But of course, if you are building a product from scratch, right, then of course you have a call to take, and then you would give a guarantee that okay, by going this approach, we are making sure that two tenants do not talk to each other for sure, correct? So that is something when you are building a product or building a platform of Kubernetes, that is a choice you have. But of course, yeah, as customer would build or have something of their own, of course, then we have to kind of at least guide them what are the pros and cons and why doing something is much better than others. And then if you are kind of putting guarantee as a product, right? No, this is what we would support and what we're going to put up, right? That's something which um, you are selling them because you guarantee say that okay, if you go this way, we guarantee that nobody else can come and talk to your workload, correct? Unless you say it. Okay. So
Thank you.
yeah, that's
Thank
a
you.
politically correct answer, but yeah, there is no fixed answer for that. Okay, fine. So let's kind of go ahead. So one is the way we discussed earlier that the namespace boundary. So basically, you create different namespaces, and then you basically use them to create multi-tenants environment on the cluster what you have there. Now, we talked about RBAC also earlier in the previous chapter. So, what is RBAC? And I assume you know that. So, with the RBAC, we can say what a given user can do in the cluster. So, for example, if I have 100 different developers in my company, I can say and assume that 10 developers in per team. So I can say that okay, this namespace belong to given service, and then or a given team, and then I would just give those 10 users access to only given namespace, so they can create pods, delete pods, deploy ingress only in a given namespace. And I can even configure that okay, whether I want the developers to create, let's say, load balancer or not. So all of those control I can do. So I can put up all of these policies with the help of RBAC. Then we have resource quota and network policy, which I think will go to come in detail later. But from the namespace perspective, we can think of there are few different ways of kind of doing it, right? One is the namespace per team. So you got, again, this is the right. You have a dev team, and you can have a namespace for them, right? Or again, same way that um, you can have the namespace per application. So I mentioned about payment, logistics, in your order catalog. Think about an e-commerce situation, right? So you say that okay, I have one namespace for the payment service or payment application. So all the apps get deployed, all the payment related app goes deploys and that namespace. Then you can have namespace per tier so that you can give, let's say, backend, front end. So that is also one way, or development stage in production. So you can put up different tiers there to set up the namespaces there. Right now, let's try to dig deep a bit more on that. How we could kind of put up this RBAC policies. Um, any questions? Anything? Okay. Fine. This I think we already talked about earlier, but let's quickly go over. So what is an RBAC? RBAC is role-based access control. That is what it means. And then we can configure a set of users or a single user what they can access in the cluster. There are two ways of doing it. One is setting up the role binding, and then if there is anything, so not mentioned here, but in the other chapters mentioned there, then we have a cluster role binding. So we can bind certain users or group of users to have a specific role in a given namespace. So role binding means you are binding it to only a given namespace. So we are saying here, like in this case, subjects are nothing but users or set of users. So we are saying all the users who are part of the group app1 viewer, they are going to have an access of view of the cluster, which means any so think about, there are certain admin users you have in the cluster, and those admin users at least can go and look at okay, so maybe I'll just take my words back. So think about, you have a set of users and you want all of those users log into or have access to the app one namespace, and in the app one namespace they can look at every object there. Now, there's a quick question here. If you can answer that, it's going to be good. So you see here, though I'm specifying the role binding, which means I'm working on a given namespace only, but here I have set up the role reference as a cluster role. So I'm planning, I'm kind of having the users, or I'm binding the users in a given namespace, but I'm using a cluster role. Any idea why is that so is being done? Is the question clear? Let me repeat again otherwise. The question is that I'm trying to work on a given namespace, which is app1 namespace here, right? But I am basically assigning the role of which is a cluster wide, right? What does it mean? Any guess?
Is this applicable only to the cluster for the namespace app1?
So
Not
name, so
not
we
for
no
not for
we
the all the clusters, only for that
no
specific cluster.
see, we have a single cluster only, right?
Okay.
In the single cluster, we'll have multiple namespaces, and there's a
Yeah.
namespace called app1,
Yeah.
right? And we have certain users in this group.
Yeah.
What we are doing, rather than assigning a role, we are assigning cluster role. So if we are creating a role, that role is applicable only for a given namespace, but here we are doing a cluster role.
Yes.
So that's the question, that why we are using the cluster role. What is the need of that, or what is the benefit of doing this way?
So
Okay, let me kind of answer that. So, yeah, go ahead.
Mr. Nabendra, that I think in the screen that YAML file is not visible.
Is it?
Yeah. Yeah. It's not visible. Actually, I'm referring other document.
Is it not visible? The policy, let me share.
Yeah.
Thanks for telling me. I thought it's visible. Let me know now. Is it visible?
Yeah. Now it's clear.
Yeah. So the question is, I was telling you, so there is this YML file. This YML is of kind role binding, which means I want to bind a role for a given namespace. The namespace name here is called app1. Okay. And we know our users also. But when we are assigning the role, we are assigning a cluster role. Why is that so? That is the question. What is the benefit of doing this way? Is the question clear? Okay, let me kind of answer that.
Yeah.
Yeah, anyone got attempt?
No. Waiting for the answer.
Okay, fine. The way it works is, what eventually we want to do is we want to have certain set of users to look at all the resources in a given namespace. Correct? That is my end goal. Let me repeat. I want certain set of users to look at all resources in a given namespace. Okay. Now there is a pre-built rule or pre-built role which is called cluster role, and here the name is view. So there are few pre-built cluster roles are there: view, add, and admin. So these are the pre-built cluster roles are available. View means if somebody has a cluster role called view, then they can look at the entire cluster objects, right? Edit means if somebody has the edit cluster role, then they can edit any objects in the Kubernetes. And if somebody has admin, they have like a full like admin access in the cluster. So these are three cluster roles which you can have. You can have more, but these are the primary ones to view, edit, and modify there all the resources there. Now, and what we know right now is view is a pre-built cluster role. Correct? Now, rather than building my separate role, what we are saying, let's reuse what is already available. Correct? So what we are saying, let's use the view cluster role, which is already available in the entire cluster. But by the virtue of putting the role binding and binding it to a namespace called app1, so we are not using the cluster role binding here, right? We are using the role binding here, which means even if I give the cluster role, it is applicable only for the app1 namespace. Hope it makes sense. So if I have to give the view access for the entire cluster, I would have to choose the kind here called cluster role admin. But I'm kind of using the role binding, which is applicable only for a namespace only per namespace. Is it clear?
Yes.
Yes, sir.
Yes.
Okay, great. Then we have the way of putting up the resource quota on our environment. Now, what does that mean is it's again a simple thing, right? You don't want the resources just used by few applications on from a given namespace. So, for example, if I have namespaces called, let's say, again same thing, right? Payment, logistic, orders. There are different namespaces are available to me. Now, I don't want the application from order namespace to take all the resources in my cluster. So, what I can do is I can set up the resource quota for a given namespace. Like in this case, I am setting up saying that I want to have a namespace app1, whatever the namespace you have been given, and this is the request and limits what we are putting up. All right. So what does request and limit means? Anybody want to take a call? What does request and limit means? Anyone know what is the difference between request and limits? Anyone? Give it a shot. What does the name suggest?
Yeah, it's the request given for that purpose and the maximum limit that we can use.
Yeah, so request typically means that um,
Yeah, in this
uh,
example, what I noticed is
mhm,
one of the requests, the example given is no zero point 0.5 was requested by the pod,
mhm.
but it is providing the maximum limit, which is 1, and limit of memory is 512 MI. Continues to that.
Okay, so let's try to define that. So request is means what is the minimum requirement my application has. So if you know that as a developer, my application minimum requirement is 1 GB of RAM, correct? Which means if you deploy the application on your cluster, right? And if 1 GB is not available, then that app is not will not get deployed. See, think about, I know that I have built an application which optimally is going to work if I have 1 GB of RAM, correct? If I get less memory, then what can happen is I can get frequent out of memory errors and so on. So as a developer, I can put up a request that how much request I want to have my application to consume or use, right? So that I can give in terms of CPU and memory. Request is what is the minimum requirement your application wants to have. Limit is how much I would want to kind of it to extend. So for example, in this case, both are same, but assume that you have given the request as 512 megabytes of memory, what has been mentioned here, but let's say limit is 1 GB, correct? Which means your application would start with minimum 512 MB of memory, but if needed can scale up to 1 GB of memory. That is the limit. That is what request and limit means. Make sense? Now, why we are putting it similar? This is because of the assignment, right? I want to basically, I think it will cover in later a bit in this chapter, but the idea is that I don't want any surprises, right? So, for example, um, my application can work best if I give it 1 GB of memory, correct? Or in this case, 512 megabytes of memory, right? So rather than having the two different limit type requests, like I would say that my application can start in 250 MB of memory, 250 MB of memory, but it would work best with 512 MB of memory. What is my requirement? I want to make sure that my application work in the best possible way. So in that case, I can put both things same, which means I am putting the minimum requirement as 512 as well as the limit as well, correct? So that way, it is kind of reserved for you, that much of memory and CPU for you. So that way, your application would work optimally. So in most situations, you will see that these values are same, but they can vary as well, depending on the situation, depending on the use case by use case. But typically, you'll find them they are same. Make sense? Any questions here?
It is clear now. It is clear now. Thank you.
Okay, great. Okay. The next point they mentioned about admission webhooks. This was covered in a great detail in the previous chapters, what we have. But just to summarize, what does it mean? Um, mm, so, so when we're deploying any applications or when putting up anything in our cluster, any object, right? What we can do is we can have some of these admission webhooks, which means before deploying my applications, I may want to kind of put certain conditions or certain requirement. So think about same example of resource quota, right? Now, though as a user, I have the permission to deploy the application on the cluster. So I would log into a cluster and so first I have log in and then I also have a permission to deploy the applications. But let's say if the quota is over, then can I deploy the applications? No, right? Let me repeat again. Though I am the user who is having the permission of deploying the application on a given cluster, I go and deploy. But if I have put up a limit saying that in the cluster you cannot have more than 10 pods in a given namespace, right? So though even I have permissions, I have put an additional logic in the system that um, you can't deploy more than 10 pods on a given namespace. Other use case you can think of, let's say I would not take any pod definition unless request and limits are being mentioned in the YML. Other use case can be I would not deploy the pod if the image is not being pulled or image is not being used from our private registry. So all of these things are enforced by the admission webhooks. So we covered this particular chapter in detail earlier, and you can look at the recording of the previous thing what we have done. So this is how we can put some of these admission webhooks to kind of enforce some of these things. So similarly, let's say when I'm deploying the applications, I can enforce that, make sure that the given team name is mentioned in the label, right? Some of the requesting, some of the guardrails. So we can put up some of these things as a part of deployment. And if you have heard about open policy agents and Kubernetes, these two software can help you enforce that. So I mentioned about the use case, right? That you don't want any developer deploy a pod which is using the image from Docker Hub. You just discard them, saying that the developer say you have not used the application or the image from our private registry. You can't deploy this app on my cluster. Correct? This is one of the very easiest way and very kind of one of the interesting way of putting the policies on your cluster. So Kubernetes is something which you should explore if you have not explored so far. Um, This I'm not too sure. This is still there or no. I don't know whether it still exists or not. This particular feature. So basically, saying that I want to make sure that I make an API calls um, with the what you call say. Let me just open this. See if I can see something there. I'll share it if it is okay. So it has been actually. Let me just share my screen. Other one. 1 minute. Well, first, let me go here only in the book. So this particular feature has become GA in the 1.29. What does this particular mechanism say? That as we know, the API server is at the heart of the control plane, which we know the API server. Now, what we can do is if one tenant overloads it, okay. So, what we are saying in this case is this feature prevents the API server from being overloaded by limiting number of requests from a given namespace or from a given number of requests handled by the config policy. So for example, if there is a namespace which is continuously putting a request to the API server, which I can limit with this. Correct. That is what has been kind of mentioned about this particular policy, this particular API priority and fairness. By this, I can control how much request I want to take from a given namespace. So that way, it is been there and implemented in the 1.29 as a production ready stable version. So I have not used it myself, but the idea is simple that I don't want just couple of applications to just keep sending a request to my API server. So I don't want to avoid that particular part. Now, similar to 1 minute. Just 1 minute. I'm just trying to get my notes here. Sorry. Yeah, so what has been mentioned in the next particular part of the chapter is the resource requested limit. So earlier, what we have seen is the resource quota with respect to per namespace, right? But now here talking about the resource quota, so I think I kind of went over the next step in the previous time itself. So I talked about this particular resource quota. Okay, this is what I mentioned in terms of the namespace. So I think I just kind of went next step on that. But the idea is here, what does the resource quota means here in the previous cases? The amount of request in CPU, whatever I'm doing is, I am putting a limit with respect to a given namespace, which means that if I add the all the requests from a different applications in a given namespace, then it cannot cross more than one CPU. Let me repeat again. So you basically assign the resources to per namespace. Let's say this namespace can have or this namespace will consume at max 2 GB of 2 GB of memory to or 1 GB of RAM, whatever. Now, by combining all the pods on that namespace with CPU and memory, it cannot cross that requested limits. That is at the namespace level. The next step, what has been mentioned here in this book is the next thing is depending on for a given application, right? So let's see if there's a YML here. It is not mentioned here, but what I'm trying to convey here, the similar requests and limits can be given for per application, or think about per container in a pod. So think about if in a pod I have two containers, right? One container says my request is 512 megabytes of memory, and the limit says 1 GB of memory. So that particular pod would require minimum 512 MB memory to get deployed on a given node. So if I have multiple nodes in my cluster, that particular pod would get deployed only on the machine where at least that much is free available for me. And that is what is being mentioned here: guaranteed, burstable, and best effort. So depending on the different request and limit policies, you can see which one do you want to kind of use here. So if you change the policy, the values of requests and limits, they will come in different configuration, right? So for example, I was mentioning about if the request and limits are same, which is like guarantee. I want to run my application where I am going to definitely get 1 GB of memory, for example. While burstable means that my I can have less requests but more limit kind of a thing, right? So there are different ways by which we can handle the requests and limits in terms of Kubernetes. So that is what is being mentioned here. Um, so here, if you look at pod consume memory above its request and is terminated. Yeah. So if you look at here, if a given pod is trying to go beyond the limit. So for example, if you said that, okay, my given container in a pod can consume at max 1 GB of memory. Now, let's say if that particular container has a memory bug, right? It's keep consuming the memory. So whenever it crosses 1 GB of memory, that particular container would basically get out of memory error, and that memory can be reclaimed back by the system. Correct? So that is what has been put up in the system, that if you hit a limit and you're trying to consume more resources, then you would get out of memory error, and that would kind of taken away from there, right? So what has been here? Pod 1 request, pod 1 use. So if you can see here, this is available total memory. This is available memory for scheduling purpose. Now what happens is, now the currently pod 1 is happy in a way that okay, I am kind of even consuming more resources because it is available for me, correct? Right? So what is happening here is, in the initial case, when the pod 1 even okay, so pod 1 was consuming more resources, though it has been given less permission for it, right? Then the pod 2 comes. Now pod 2 wants memory, right? Because pod 2 requests some memory, we have to give it. And now we have to kind of terminate the pod because this particular pod may have used more memory than it has been allocated, and then it's going to kind of we have to reclaim the memory from there. That way we will take the memory back from the system. That is one way of looking into it. Then what is also there is you can also configure something called as priority classes. So you can configure different priority classes, which is not mentioned in this particular book, but it is the feature may have at a later point of time. So what is that? You can define different priority for different kind of applications. So when the higher priority application comes, and if it needs resources, it can kill some of the lower priority task. That can also happen. Correct? This is a way by which Kubernetes can manage resources effectively on the system. Any questions? Okay, fine.
Is
So,
that
no question, but comment. I would say our developers are always requesting more memory than the operations people measure being used.
Correct.
Always.
Yes.
And so it's an engineering challenge, both spilling into a management policy challenge.
Mhm.
And so I'm looking to see if the text has any best practice on.
So it is not mentioned there. So the way to handle it basically is you need to look at the. So that's why we do this monitoring of the entire system, right? So for example, if you have configured something like Prometheus or other monitoring tools in your environment, right? And once when the application is running in the environment, and if we can find out the average, or basically we can look at the best or how much the memory is required by that application at a peak time, for example, right? So once you monitor the application for some point of time, you know how much memory is required by the given application. That is why monitoring is very important. Then you set up the monitoring in your environment. Then you look at the pattern of the uses of the application, and then you kind of tell, see, the developer, we don't see your applications going beyond this. Correct? So that is the best thing you should configure right now. That is how we have to kind of tell the developer the data. Your application is not going beyond certain. So you kind of maybe, okay, maybe we can start with, okay, give higher memory for whatever the developer asking for first 1 month, right? And look at all the scenarios and tell them that, okay, see, this is your application does not require more than this. Or of course, you can always scale the application, right? If there's a more requirement for you. Correct. So rather than saying that, okay, you allocate more upfront memory, why not scale the application? And that is why we have some of these auto scalers in the Kubernetes cluster, right, available for you. So when you know that, okay, if your memory consumption is going beyond certain percentage, you scale the application. So the way to tackle it is only by telling the data. This is the data what I see from your application. Rather than giving more memory to a single app, why don't you scale the application? And that way you will have more resources available. And then of course, when the traffic goes down, your app shrink automatically. Correct. So putting the monitoring in place and coming up with some of these auto scaling policies would be the way to go, I believe. Make sense?
Well, yes, it makes sense. Some of my customers are running in Azure and AWS, and this actually translates into monthly bills.
Yeah, of course.
And so it's an engineering economics problem, and not
Yeah.
necessarily an open source Kubernetes technology problem.
Yeah, so there are some solutions that are being built for that actually. Like there is this open cost and there is this cast.ai. Some
Yeah.
of these companies have built some of these things and they basically scale your applications, what I'm saying, right? Rather than kind of giving upfront unlimited resources to application, they put up this policy of auto scaling. So if you have some kind of intelligence saying that, okay, at every night, whatever, like, or every day at whatever 3 to 4 p.m., you have more customers coming on a website. Why not scale them upfront, for example? Correct. So CADA and some of these things can be helpful there, right? So of course, looking into this auto scaling solution like Carpenter or whatever they have, right? That was the way to go. Yeah, okay.
Yes.
Fine. The next part here is talking about the CPU resources. So we have around 6 minutes left. I think we can finish the chapter because there's not much left here. So we'll finish the chapter and then we'll start the next one from the next time itself. Just give me maybe 5 minutes more to kind of close the chapters. Yeah. So the next part mentioned here is the CPU, right? So now, what happens in terms of Kubernetes or in terms of Linux in general? If you know the concept of C groups, right? So C groups are nothing but a way of allocating resources to your applications in Linux in general, right? So the way it works is we kind of tell one CPU is equal to 1,000 millicores. That is how we kind of generally depict, right? So either you can say that I want to allocate one CPU, you can say one CPU as a thing, or you can say 1,000 as a number. So what we saw earlier, request and limits, if you look at here, not been mentioned here about the this one, right? So here, what has been mentioned here, if you can look at here, right? So it is mentioned here, request CPU, it can go up to one CPU, but it is the request is 500 M. This is millicore. So we kind of tell our system to allocate CPU in terms of millicores. So one CPU is generally referred as 1,000 millicores, right? Now, what does that mean? So again, this is a number here. What does this number mean is if there are multiple programs are running, and if they are requesting, like for example, in this case, it has been mentioned here, if process P1 has 2,000 shares and process P2 have 1,000 shares. So the way it works is, what I'm telling is, though I may have only one CPU, and I can say uh, process 1 has 2,000 shares or 2,000 number I have given there, and for P2 I have given 1,000, which means I have to kind of divide one CPU in terms of 3,000 shares. So what happens in that case is, because I have given twice as the number to P1, so P1 would get 2/3 time and P2 will get 1/3 of time. That is how you have to kind of look at the numbers here. So basically, we kind of add those CPU in terms of millicores, and then once we have the overall count available with us, we kind of course, know that how much CPU are available in the system. So for example, if I have a system with 12 CPU, I have 12,000 shares available with me, correct? And then when I'm deploying my application, if I mention 1,000 CPU, 1,000 share, which means if all the CPU are being used, again, remember the term here, what I'm saying is, if all the CPUs are being used, then I can get 1/12 of it. Otherwise, I can actually use all the CPUs. So what Kubernetes does is, if you have given shares, these shares are only getting kind of come into enforcement only if you have other programs consuming the other resources what is there. If not, then actually this particular program can get all the CPUs and finish the work faster. So it is not that you are trying to say I would give you only 1,000 share only. No. If the remaining CPUs are free, then you can consume as much as you want. Correct? Otherwise, if all the CPUs are being used, then this is a share. Correct? That is how you have to kind of understand. Does it make sense or no? What did I mention right? Does it make sense? Okay. Let me just try to quickly summarize one more time and hope it would make sense. See, if you're deploying an application, right, and if you have all the CPUs available with you available for free, available till they're not being used by anything, right? Then what is the ideal case? My program consumes all the CPU and finishes the work faster, right? Why do I want to kind of do some work and wait and then come back and again do it? Does it make sense? Yes or no, guys?
Yes, yes.
Yeah.
Yeah, clear.
So that is the case, right? So what I'm trying to convey here is, if the CPUs are available for free, I would try to consume them as much. But if they are not free, then the enforcement of this code, this particular course come into existence, right? So in that case, if I have to kind of divide, how would I give priorities? So depending on the share value I've given to a program, so I would consume the entire. I will kind of calculate the percentage based on the share count I have given, and based on that, P1, if you have 2x shares, you get 2x CPU. That is how I would divide the entire CPUs there. Correct? So now, for example, in this particular case, what is mentioned here, by default, Kubernetes sets the period for 100 millisecond. A container with the limit of point CPU, you can see it is going to have 50 millisecond of the CPU available every 100 milliseconds. So what is happening here is, if you can read it, by default, Kubernetes says that if you assign one application as one CPU, by default, we are giving you 1,100 millicores, 100 seconds, right? But if you given 0.5, then will be given 50. If you given 0.25, you will get 25 milliseconds. That is how Kubernetes calculates how much CPU you would be getting. Correct? And so what happens is, you run for 50 seconds, then you may kind of maybe what do you call, say, throttled by for other programs. Then again the request comes, then again between 100 and 200 you will get 25, for example 25 here, 25 here. So you will get two batches of for every 100 milliseconds you get 50 milliseconds. So what I'm saying is, if I am having 100 milliseconds, but I have given zero point 0.5 CPU, I would be getting 50 CPU running time. Again, that has been considered if it is being used by the other programs. Otherwise, you will consume the entire CPU. So let's not go too much into deep, but what general sense is there. If CPUs are available, use the entire stuff. If not, then you would be given in terms of the 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 CPUs you have mentioned there. Like in this case, if you have mentioned 0.5, you will get 50 milliseconds. That's the number what is set by Kubernetes. That is there. This is the older kernel bug problem, so you can ignore it, not a problem. Just kind of get rid of it. Then again, there was network policies. So again, when I configure different namespaces, I don't want the namespace, or so I don't want app from one namespace to communicate with the app of other namespace unless I want it, right? So only if I want, saying that okay, the app from the payment application or payment namespace can talk to the service of order gateway or the order service, then they can communicate. So that a policy we kind of
Can
went
you
into.
please move to the policy page, please?
Which one?
No, now this page which is visible is not network policies.
Is it not?
Yeah.
It's happening for everybody else or just for one person? What do you see? That a policy, something else?
No,
Nice.
now it is 366 is visible. Actually, I'm following up the book in my ebook also. So, but in the screen,
Can
it
you,
is
for
showing.
anybody else? For anybody else? What do you see right now? Is network policies or no on the screen?
Yeah, I can see the screen. So it might be something related to the network, but I can see your screen.
Yeah, okay. Well, I'll reshare it. So just make sure that it is there for him as well. Okay. So network policies we covered in detail in the previous chapters. Chapter 5 is there. But what does it mean with the network policy in general is, I want to control both incoming and outgoing connection to my pods, correct? I want to control who can talk to me or whom I can talk to, correct? As an admin, so I can control that. That is what network policy. So what this particular portion of the chapter says that when you create a multi-tenant environment like multiple namespaces, ideally you should basically configure the network policies accordingly as well, right? You don't want the app from one namespace communicate by default with another namespace, right? So again, you can go back to the chapter number 5, look in detail, but that is what is there. So what is the default way of doing things is you first say default deny. You don't allow any incoming or outgoing connection from your pods. Then you open up slowly as per the requirement. Correct? That is how generally it should be done, that you first say deny all, then you open up whatever you would wish to communicate between. Yeah. That is what is being mentioned here. Then there's something called as pod security policy, which is no longer kind of active on Kubernetes. But the point here is you want to kind of control the uh, the enforcement of policy, like the way I mentioned earlier, right? Let's say I don't want any application to run in my cluster with a root user, right? Like the way it is mentioned here, right? Must run as. So what I'm trying to convey here is, so if I try to look at what does this PSP or what is PSP was there, what is the rule here? Must run as non-root, which means when I'm deploying my pod, inside the pod, when I run the application, it should not run as a root user. Correct? That was the PSP policies what been configured previously, but now you have the software like Kubernetes and OPA that is basically implementing that. So again, we covered this thing in the previous chapters. So if you want to look at Kubernetes, you can go back to the previous chapter and take a look, or recording at least in the admission policies, or you can look at the documentation. All this kind of covers in detail. So then PSP, now people prefer the software like OPA and the Kubernetes, which sits in between your actual app deployment and the API server. So you can kind of control that. Then what has been mentioned here is, yeah, like the what I discussed earlier, that think about when you're deploying this software like logging, monitoring, and so on. Do you want to deploy them for the entire cluster, or you want to have, let's say, per tenant, right? Because it may be required that, okay, I don't want one of the customers or one of the applications or one of the admin look at the logs of the entire cluster. I want to have a separate setup, right? So for example, I would send the logs of the payment in one cluster or one Prometheus cluster. Not the logs per se, but whatever the metrics I have available there. Similarly for, of course, logging as well. But what I'm saying is I would separate out even the monitoring, logging, and other thing per namespace level, so that my some of my customers cannot see logs of others and so on. So that is something which you have to take into account as well. That is how, that is what in this book is being covered, that when you're deploying the multi-tenancy, what are things you have to take into account. So in short, namespaces, then how do you allocate resources to namespaces, network policies, and the resources per application. That is the main thing you have to take into account if you deploy the multi-tenant environment. Yeah. Hope it makes sense. Any questions?
Yep, it's okay.
Great. Okay.
I found it very useful. Thank you. I'm going to download the book.
Yeah, please do that.
It interests me.
Yeah, it's a good book, and then of course you can watch the previous recordings and so on. And we also published a couple of quizzes which you can find in the Slack channel if you want, or I can give you the link of the things which I have put down on my website as well. So you can actually take the quiz and see your readiness of the production Kubernetes, and then maybe go back to the chat and do that. So I'll give the link here.
Perfect. I will appreciate if you share the links of the quiz because you
Yeah.
mentioned before and I couldn't get it. So
Yeah, I'll do it right now.
thank you.
So on the chat, you can
Yeah,
see that.
thank you. I got it.
There are two quiz we have published. So one quiz we've taken together as a class, and the quiz two we published later. So this is again on our website. But of course, we did a open version of it in the session, and then I put it on my website. But we'll get the scoring and everything with this. Yeah. Um, okay. So the last question is, as we move for the next chapter, anybody want to volunteer for the next chapter to kind of take lead, auto scaling? Okay, it's okay if not, but you should target for the next time, maybe some other time, because only that way we can kind of do things together and then learn better. Yeah. Okay, so we are good for now. What we'll do is we'll try the next week and then look at the next chapter of auto scaling. So either myself or Abdul would take the lead there. Yeah.
Thank you.
Okay. Sounds good. Any questions or any feedback you have?
Oh, thank you so much for leading the chapter. I appreciate it.
All right,
Thank you very much.
Thank you. See you next time. Bye.
Bye bye. Bye.